second graders, we have another science video for you guys today where we are still working with reversible and irreversible changes. Smart part, what pages are we going to be on today?
Hey, today we're going to be doing pages 71 to 74 in your workbooks.
Awesome. So we're using the same materials we used yesterday, but we're actually going to make those predictions come to life. We're going to see, are they true? Were we correct? We're going to watch some videos to show them getting tested and seeing if we were right. So first, let's look back at our predictions and put them back on this page so they're closer to where we're working today. So yesterday, let's start with the egg. We had a raw egg, we applied heat and cooked it. We decided that we thought that it was an irreversible change, that we're not going to be able to get that raw egg back. Okay, and then we had a block of butter, we applied heat, melted that, and we thought, hey, if we cool it or if we leave it out, it'll probably get hard again, it's reversible. And then finally we had that glass of orange juice that was frozen, and we decided that if we unfreeze it, we heat it up, we leave it out, it'll turn into a liquid again, so that it's probably reversible. So we'll check mark our predictions to remind ourselves what we thought, and then we're actually gonna watch some videos right now to test our ideas, test our predictions, and see if we were correct. See if these changes are reversible or irreversible. So what we're gonna do right now, I'm gonna walk you through this. We're gonna watch the video of the egg being heated and turned into a solid from a liquid, and then we're gonna watch to see what they do to test that and see if it can turn back. See if it is reversible or irreversible, and then we'll fill this section out. So Ms. Marquardt's gonna show us the video and we'll see what happens. Doesn't look like it changed back.
No. It didn't look very good to eat.
I don't think I want a cooked cold egg. That sounds gross.
Kind of gross.
Yeah. Let's talk about the first section. So at the very beginning of the video, they cracked that egg into the frying pan, and what did they do to change it into a solid?
They added heat.
They added heat. So that's all we're going to put in this first one. How was that original change made from turning it into a liquid into a solid? Adding heat. Okay, so heat was added. Then they did something kind of weird, which we wouldn't normally do to an egg after we have fried it, is they decided, well, if applying heat to it is what caused it to change into a solid, then applying cold temperatures to it or freezing it or cooling it must make it turn back into its original liquid form. So they put it in the refrigerator.
The egg was cooled.
So that's how it was tested. It was cooled. It was refrigerated, however you want to say that. Cooled is a lot easier to spell than refrigerated, so we'll probably stick with that. It was cooled. I put it in the refrigerator, and then when they took it out, was it a liquid raw egg again, or was it still a solid cooked but cold egg?
It was a solid cooked cold gross looking egg.
So was that change reversible? Did they get back to its original form?
No. Irreversible.
Irreversible, meaning IR means not. It is not reversible. Not a reversible change. So we were correct. Our first prediction was correct. The egg is not a reversible change. Now we're going to watch a video on the juice. So we're going to watch in the video, how did they originally change it from a liquid to a solid? That will be our first thing. Did they heat it? Did they cool it? Then how did they test that to see if it can turn back into its original form? and then was it reversible or not? So let's see. I think I saw a change back at the end of that video, Ms. Marquardt.
Yeah.
Okay, so originally at the beginning of the video they had that glass of orange juice. What did they do to make it turn into a solid?
So this time they put it into the freezer. So we could write that it was cooled, or we can even say it was frozen this time.
All right, sounds good. So that original change was made in the freezer and it was frozen. Awesome. And your freezer is a lot colder than your refrigerator. Your freezer is like 15 to 20 degrees Fahrenheit, which is like way below freezing, in order to keep things literally frozen like ice. Your refrigerator just cools things off, so it's a lot faster to put something in the freezer if you want it to cool off. So we turn it into a frozen ice pop in the shape of a cup.
Which is hard to lick.
It's hard to lick it. Yes, exactly. And they wanted to see, okay, it's frozen. You could see they tested it. They put their spoon and kind of jabbed at it, and it didn't change its shape. It just kind of held solid in its solid form. What did they do in order to make it become unfrozen? Back to liquid.
So this time they left it out, and we could say that it was melted. So they didn't really apply heat, but just putting it out in room temperature was the heat that was added. So we could just write it was melted.
Yes, it was melted, which is, it was melted, it was heated. When you're taking something and going from a really cold temperature into a warmer temperature, that's heating it. Even if you're not actually applying a flame underneath of it, if it's been sitting in the 15 to 20 degree freezer and then you bring it out into like a 70 degree room, there's a big temperature change there. That's still considered heating it. And then it melted. And so it went from solid back to liquid. So it was reversible.
Yeah.
It was a reversible change.
And that fits better.
Yes.
In this space.
It does. All right, so the last one we're going to test, watch being tested, is our butter. Let's see what happens. Wow. Very cool.
Can I tell you something?
Tell me.
That seemed like a lot of butter.
It did.
I mean, could you imagine cooking with that much butter?
That was a lot of butter.
I usually just use
probably
like
tastes
a little,
good because butter makes everything taste better. All right, so originally they started off with a nice rectangular prism, stick of butter. What did they do to make that turn into liquid?
Well, they applied heat and they melted it.
Yes, awesome. They applied heat and they melted it. Excellent. You guys seeing a trend here? Heat applied, cool temperatures applied, causes a change in properties.
I might even write in parentheses here.
Melted.
Melted.
Awesome.
It was really built.
All right, so once they melted it, they took that whole pan of melted butter and poured it back into like this like bowl type thing, and it was liquid. Then where did they put it to test it and see if it would turn back into a solid?
Back into the refrigerator.
Yes.
So pretty cold in there.
Yes. So they did the opposite of heating it, which was cooling it off in the refrigerator to test and see if it could turn back into its original form of solid. So it was cooled. And then when they took it out of the freezer after some time, or out of the refrigerator after some time, what did we discover?
It was a reversible change.
Yes.
We ended up getting butter again.
Yes.
It
Did it
didn't
look as
look
good? Yeah. Yeah. You might have, okay, here's the big debate in life, I think. And you guys might not notice this because you're probably always only at your house and you don't go to a lot of other people's houses and look at what they do with their butter. Do you, or in your family, keep your butter in the fridge all the time? Or do you use a butter dish and leave it out so that when you want to toast your bread, or I mean butter your toast, that it's already soft?
Oh. Well, I'm curious.
What do you, I'm curious.
Okay.
What do you guys do in your family?
So, can I tell you, as a child?
Yes, it's different for me too, as an adult and a child. Let's
I'm-
hear it. Let's
oh,
hear
I
it.
can't wait.
Let's
This
hear
is
it.
exciting. So, when I was a kid, my mom had a Tupperware butter dish, and it stayed on the table all the time.
Uh-huh.
But as an adult, I put mine in the refrigerator, but I cheat and I buy the spreadable butter so that when I take it out of the refrigerator, it's easy to spread. Because I do not like hard
Interesting.
butter
I don't like hard butter either.
on my toast.
It's
so
annoying, huh?
I think I know what your answer is.
I don't think you do. What do you think?
Really?
What do you think?
I
Tell
think
me.
that as a child, your mom left it in the refrigerator. And
Yes,
as an adult,
you do
leave it
now,
out.
because you know I leave my butter out.
No, I don't.
You guys don't care about this conversation
No.
at all, but it's like really big. And your parents, if they watch this video, they're gonna be like, "Yeah, I know what you mean. My
Yeah.
mother used to do this, and I do this." When I was growing up, we were a family that the butter was always in the fridge, and I was like, "Gosh, every time I take this butter out and put it on, it rips my bread. It's annoying. It's hard."
Sounds like you had a difficult childhood.
Yes. And then now, as an adult, I'm like, and then whenever my mom comes to visit me, she's like, "Why do you leave the butter out? It's all gross in this butter dish." I'm like, "It's not gross, Mom. It's like
ready
meant
to
to be.
use.
It's ready to spread, and it's
Yeah.
nice and oh."
You should try spreadable butter sometime.
But I really like the taste
Like
of
real butter.
real butter.
I'm not that picky.
Yeah. Anyways, you guys,
Are
that
we-
was a long conversation.
We're
about
still
butter.
going.
Yeah.
Yeah.
So I challenge you to think about that in your household. Are you a household where, well, I'll tell you what, when we haven't used the butter yet, it stays in the butter thing in the fridge until
Yeah.
we need a new stick of butter,
Yes.
obviously, and we put it in the butter dish.
Same.
But are you a family who has a butter dish and it stays out at room temperature so it's easy to spread? Or are you a family where the butter is always in the fridge? Or are you a third family like Rachel's, Miss Marquardt, who has spreadable butter in like a tub?
Hey.
Interesting. All walks of life, right?
Things you learn.
Yes. You live and you learn. All right, here's a challenge. Tell us what this challenge is. I see an ice cube.
I see an ice cube too. It says an example of another reversible change is, so, I mean, you could use this really helpful picture if you wanted to, but the challenge is for you to come up with another reversible change. Another change that if you were to heat something, but then you cool it, you get the same thing back. Or something that you cool and then heat, you would get the same thing back.
And here's a really good hint for you.
Yeah,
There's
wow.
a picture of it all over this page. If I were to heat whatever this picture is, it would turn into like water. And
Sure
then if I
would.
were to freeze it again, it would turn back into this guy right
Probably
here, right?
that solid
So
ice
it's
cube.
probably reversible.
But you want to challenge yourself to think of something else at home,
You
you're
can do
welcome
that.
to do that. I wonder if like milk would do the same thing.
Probably.
Things you got to think about.
Yeah.
All right. And then finally, I know this change is reversible because, tell us, how do you know that? How do you know that it's reversible? What did you end up getting at the end of the change as opposed to what you had at the beginning?
All right, and then there's one last thing, our reflect for the day. So let's see what's happening here. Read the claim. I left a piece of bread in the toaster for too long and it burned. I hate when that happens. It's the worst.
It
It
is.
smells bad too.
Ugh.
Before, it was soft and brown, but now it is hard and black. It's okay though, because I know that all changes caused by heating and cooling are reversible. Once the bread cools, it will go back to the way it was. Do you agree or disagree? Very, very interesting. Well, first of all, Miss Marquardt,
Yeah.
we tested 3 things And not all of them were reversible.
No.
What was reversible?
Well, I remember the butter.
The butter was
we were
reversible.
able to get the butter back. And I remember the orange juice we could
juice.
get back.
But the egg,
No way. Did you see that egg?
yeah, we could not return that to its original form.
No.
Okay, so I'm sure a lot of you guys have made toast in your life, okay? That's one of Mia's favorite things to do is put a piece of bread in the toaster, toast it, and then put butter on it and eat it. Kids love toast, right? So, do you agree that if you burn a piece of toast and you leave it out sitting on the countertop for long enough, that black burned spot will just magically disappear and it will go back to being a soft piece of bread?
And disappear doesn't mean like a
You
grown
cut
up
it
got
off.
home and threw it away.
Yeah.
Oh,
like
there
it's
it's
just
gone.
all the black miraculously vanishes. Is that going to happen? No. Okay, so do you agree or do you disagree?
I disagree.
Yeah.
But they can make up their own mind, I guess.
And here it says use evidence to explain your reasoning. How do you know that a burned piece of toast is not going to go back to being an uncooked, soft piece of bread? Do you know from experience? Do you know because from our other experiments we have proven that not everything is reversible? How do you know? We look forward to seeing what you write down. And that is it for today.